Hello, welcome to the new section, Working with Pattern. The topics we are going to discuss in this section are pattern matching and monad as a design pattern. Pattern matching will match the condition using mathematical approach so that we get a functional taste of things. Using monad, we can give more power to existing data types by amplifying their behavior. Let's start with the first video of this section, Dissecting Pattern Matching in Functional Programming. In this video, we are going to discuss the pattern that will make our code flow in a regular order so that it will be easier to maintain and understand the flow of the program. In functional programming, pattern matching is a form of dispatch to choose the correct variant of the functions to be called. This is the getFactorial functional we use to retrieve a factorial value. As we can see in the code, it gives us two definitions. In this case, the dispatcher is chosen based on whether the actual int number parameter pattern matches 0 or not. The use of pattern matching is closer to this if conditional expression, since we have to decide which section will be selected by providing a specific input. Pattern matching is somehow transforming data. As we might remember, we had a function in the extension method called isPrime to check whether or not it is a prime number. We will use it again to demonstrate pattern matching to transform data. For those who have forgotten the implementation of the isPrime function, this is the code. Again, we use pattern matching to determine whether the number is a prime number, composite number, or neither. However, now we will transform the int number into text, as we can see in the number factor type function, which we can find in the matchingpattern.cs Proj project. As we can see in the code, we use the if-else conditional statement to match the condition instead of the if conditional statement we used in the previous example. Now, let's call the number factor type function to match the int number we give and transform it into the text using the transform int into text function. We pass the number 0 to 9 in the number factor type function to get a matching result, and if we run the transform int into text function, we get this output on the console. As you can see from the output, we have successfully used pattern matching to transform int into text. Now, moving on to switching for pattern matching. We know that pattern matching can transform data into another form. This is actually similar to the select method in LINQ and conceptually similar to the switch case statement. Take a look at the hexchar to byte function to convert a hexadecimal character into byte. Then we add a wrapper to convert the hexadecimal in string into int, as shown in the hexstring to int function. From the code, we can see that we call the hexchar to byte function to get each int value for each hexadecimal character. Then, we use the power of 16 to get all the hexadecimal values. Suppose we have this getIntForm hexstring function to convert several hexadecimal digits in a string into int. If we run the getIntForm hexstring function, we get this output on the console. Each hexadecimal character in the string is converted into the int value, and then it sums up all the results. Moving on to simplifying pattern matching. We have successfully used the switch statement to implement pattern matching. However, the example doesn't apply a functional approach, since the rest variable in the hexchar to byte function is mutated during execution. Now we are going to refactor the hexchar to byte function in order to apply a functional approach. Let's take a look at the hexchar to byte functional function, which can be found in the simplifying pattern matching.cs Proj project. The hexchar to byte functional function is refactored from the hexchar to byte function and now implements the functional approach. We have four methods similar to the switch statement or the if-else condition statement: match function, with function, else function, and do function. Let's take a look at the match function used by the hexchar to byte functional function. As you can see, the match function returns the new pattern match context data type. And this is the pattern match context class implementation. When the match function generates a new instance of pattern match context, the constructor stores the value passed as an argument to the value private variable, as shown in the code snippet. In this pattern match context class, there is also a method called with, which we can compare with the underscore value. The method will invoke the with method inside the pattern match on value class, the implementation of which is like this. As you can see from the code, when the with method, which is a member of the pattern match context class, returns a new instance of pattern match on value. Its constructor also stores the value to the value private variable, as you can see in the code snippet. It then calls with method, which is passed on anonymous method as condition and an expected value as result, as shown in this code snippet. The with method then calls another with method, which passes predicate tin and functional tin and tout, as shown in the code snippet. This with method collects all cases and stores them in the cases list typed as pattern match case, the implementation of which is as shown. This is the code. I've highlighted it here. Once we have provided all the conditions, we call the else method, which contains the default result. The implementation of the else method is as shown in this code snippet. We then invoke another else method basing function tin, tout, as shown in the code snippet. After we collect all underscore cases and else case variables, we have to invoke the do method to compare all cases. The implementation of the do method can be seen in the code snippet. The do method will assign the underscore else case variable, if any, to the underscore cases listed, using the with method as shown in the code snippet. It then compares all underscore cases list members using the for each loop to find the correct underscore value using the code snippet. Although invoking the else method is optional, it's mandatory to match one of all the with method invocations. If not, the do method will throw an incomplete pattern match exception, as shown in this code snippet. For now, we don't need to implement anything in the incomplete pattern match exception, so we just need to create a new class implementation exception class, as shown in this code snippet. Until here, we have successfully refactored the hexchar to byte function into the hexchar to byte functional function. We can modify the hex string to int function to invoke the hexchar to byte functional function, as shown in the code snippet. However, the hex string to int function does not implement the functional approach. We can refactor it to the hex string to int functional function, as shown in the code. From the hex string to int functional function, we can see that first, we convert the strings into a list of characters by revising the order of the list. This is because we need to assign the least significant byte with the lowest index. We then select each member of the list and create a new class that contains the character itself and the index. Afterwards, we sum them up based on their index and value. Now we have to get int form hex string functional function, and it invokes the hex string to int functional function. Now let's run the hex string to int function. This is actually similar to the get int form hex string function. We get the exact same output compared to the get int form hex string function in the matching pattern.csproj project, since we have successfully refactored it to the functional pattern matching. Let's see pattern matching. The planned language features in C#7 includes pattern matching, which has the extension to the is operator. We can now introduce a new variable after the type, and this variable is assigned to the left-hand side operand of the is operator, but with the type specified as the right-hand side operand. Let's make it clear using the code snippet, which we can find in matching pattern C#7.csproj project, and this is the getData function implementation. In this operator before C#7 function, we should assign s variable with the value of o after we check the content of the o object variable in if statement. It is what we can do before C#7 introduce pattern matching feature. Now let's compare the code with this one, that is, the is operator in C#7 function. As we can see, we now can assign s variable with the content of o variable, but with the string data type, as we have discussed earlier. We assign the s variable inside the if statement when the condition is checked. Fortunately, this feature can also be applied in switch statement, as we can see in the code snippet. In the switch case in C#7 function, we can assign s and I variable with the content of x variable in the case checking, so we don't need to assign the variable again. Now let's run switch case in C#7. Cool. That's what we get as an output. 1 is an odd integer. In this video, we learned dissecting pattern matching in functional programming.